Hello, grade 4. I hope that all of you are healthy and safe. Today we are going to check our homework concerning the last session, Unit 5, Electricity. Please open your workbooks and try to check with me as much as you can. If you have any confusion concerning the questions, please repeat the video as much as you can, as I'm going to explain each question right now. Okay, let's start. The first page in your homework is page 56. In this question, he asks you to look at these circuits and say which one will work to light the lamp and which one will not. The one which is going to work, you have to say yes, and the one which will not work, you have to say no. Before we started, did you remember the components of the circuit? We said that the circuit must contain a battery and wires, which is going to connect the battery to the lamp to light it up, and the lamp is placed on a lamp holder, okay? And as we said before too, the battery is the source of electricity, and the wires are the conductor, which is going to help the electricity to flow in the circuit. And the most important note that the circuit must be complete circuit so the electricity can flow easily and the lamp light up. So if we have any break or gap, we said it's a circuit break and the lamp will not work. Let's start and see each picture illustrate what condition. Picture A, what do you think? Of course, the circuit will not work because there is a very big gap in the circuit. There is a missing wire from the battery to the lamp holder. So there is a circuit break and it's a gap. So the electricity will not flow easily. Question B, the circuit will not work too, but why do you think? Some of you may say because there is a gap, but don't you know that there is no battery, there is no source of electricity at all. So the circuit will not work. Where is the source of the electricity? So circuit B will not work because there is no battery or cells. Question C. I said that this circuit will not work. But many of you may say, no, we have a battery, we have wires connected together, and there is no gap in the circuit. But there is no lamp. What is going to light up? We have no lamp to change the electricity into light. So this circuit will not work because there is a missing component. What do you think about circuit D? Circuit D is more than perfect complete circuit because we have source of electricity, here is the batteries, and wires connected completely all over the circuit, and a lamp which is going to light up. So circuit D is going to work, yes. What do you think about circuit E? Circuit E, of course, will not work because there is a huge gap between the battery and the wire. There is no direct connection between the wire and the battery. There must be a complete wire reaching the battery so the electricity can flow easily. Concerning circuit F, we have a battery and we have circuit, complete wire, and a light bulb or a lamp. So this circuit is going to work very well. Okay, next page, page 57. We are going just to answer question number 1. Okay, we have a word bank containing some words and he asks you to complete these sentences. Please concentrate as much as you can. We have complete, circuit, flow, cell, break, and light. Question A. We can use electricity from A to make a lamp light. He asks you from where we are going to take our electricity. Where is the source? And as we said before, we have two sources of electricity, either main electricity or battery and cell. So in these words, we only have cell, so the answer would be a cell. We can use electricity from a cell to make a lamp light. Okay, question B. Electricity only flows around a circuit when there is a what circuit? Yes, of course. There must be a complete circuit so the electricity can flow. And so, as in question C, when there is a complete circuit, of course, the lamp will light up. Very well. Question D. When there is a gap in the circuit, we say there is a what in the circuit? If we have a gap, as we said before, we say we have a gap in the circuit. It's called a circuit break or a break in the circuit. Question E. If we have, or if there is a break in the circuit or parts don't touch properly, there is something wrong with the component, the electricity will not what around the circuit. Of course, the electricity will not flow because the electricity needs a complete circuit to flow easily through the circuit. Okay, F. When there is a break in what, the lamp will not light. If he asks you about a break or gap, there must be a circuit because the gap and the break happen in the circuit. So when there is a break in the circuit, the lamp will not light. Please turn the page for next page, page 58. In this page, we also gave you some types of circuits or some different circuits and ask you to write down if the lamp is going to work or not, and you have to state the reason. So let's have a look on the first picture. We have a lamp, wires, and battery. But if you have a look, you are going to find a very big gap between the wire and the lamp holder. There is no wire to connect the components together. So this lamp will not light because there is a missing wire and the circuit is not completed. Second circuit, have a look. You're going to find a lamp and wires and battery, but there is a huge mistake that the wire is connected to the glass lamp, not to the lamp holder. The glass lamp, as we said before, glass is an electric insulator. It does not conduct electricity. So the wire must be placed on the lamp holder because the lamp holder contains the metal which is going to connect the electricity from the wire to the lamp. So in this circuit, the lamp will not light because one of the wires goes to the glass lamp. So the circuit is not complete. Okay, what do you think about the next circuit? I think the next circuit is a perfect circuit because we have a light and we have an electric source, battery. We have connected wires all over the circuit and we have a light which is going to change the electricity into light. So this is a perfect complete circuit. And the lamp will light because there is a complete circuit which allows the electricity to flow. What do you think about the last circuit? Did you know that there is something missing? Yes, very well. There is no cell. There is no batteries. So from where did this circuit going to take its electricity? What's the source of the electricity? There is no source of electricity. So the lamp will not work because there is no cell or there is no source of electricity. If you wrote no batteries, it's good, it's fine. It's a correct answer. Okay. Next page, page 60, we're going to answer question number 1. If you would like to answer question number 2 by your own, it's okay. It's just a research. You can do research and use YouTube and use Google Chrome for searching, Google Chrome Kids. You're going to find many interesting information. Actually, I'm encouraging you to use YouTube Kids or Science Kids so you can see more and more information about cells, batteries, and electricity and different circuits. It will be very interesting and you may have many and many entertaining during this. I think that all of you have a lot of time to make such things. So please try to search and know more information about electricity. Okay, question A, question 1. We have many different batteries here. A torch which is working with 2 cells as shown, a single battery like the one you used in your remote control for the television, and this large battery which is used in the cars, and some different other batteries. He asks you to make a list. In question A, he asks you to make a list of 8 electrical appellants that use single cells and batteries. He asks you to write 8 electrical appellants that use batteries. Don't need to use main electricity as well. So many toys use batteries. Torches use batteries. Your doorbell, do you know that your doorbell usually use battery? Portable radios, your hand watch, and of course your mobile phone use battery. However, your mobile phone, his battery needs to be charged, but it depends on the battery. If there is no main electricity, it's going to work. Also your calculator use a battery. You don't need to have a plug and socket to use your calculator. Also laptops can be recharged like the mobile phones, and it's also known as portable computers because you can move them from one place to another without using a plug and socket. In question B, he asks you which electrical appellants in this list you think use the smallest cell or battery. What do you think? I thought that the watch is going to use the smallest battery. Do you know why? Did you ever see a battery in the watch? Here is it. Those, I'm circling them with red. They are look like the cell of the battery or the cell of the watch are look like circles. We usually use one battery, which is a circular battery, for our hand watch. So this is one of the electrical appellants in the list. We think that it uses the smallest cell or battery. Okay, turn page 62. We are going to answer question number 1 only. Okay. He asked you that class 4 did a test to find out what would happen if they kept adding more lamps to their circuit. Did you remember the volts? Did you remember the pushes that the volts give to the circuit so the lamp can light up? Did you remember that we said if we add more batteries, our lamp will be very bright, but if we add too much batteries, the lamp will be destroyed? And on the contrary, we said that if we add too much lamps on a small volt, these pushes is going to be divided or distributed on all the lamps until the lamp is going to be dim or dark or with a low light. This is the point of this question. He asked you to imagine that you're going to add some numbers of lamps and see what happened in the circuit. He told you that he placed one lamp and he found out that this lamp is very bright. And that's logic because this lamp just took the whole pushes or the whole volts for its own. Then he asked you that he add 2 lamps. What do you think is going to happen to the circuit? If we add 2 lamps, if we add another lamp here in this circuit, we're going to find out that lamps are equally bright. They are going to be bright as equal as they are because the pushes is going to be distributed on 2 lamps only. So they will be equally bright. But then he told you that when he add 3 lamps, he found that the lamps are dimmer. Started to be with low light, dim, little dark. So what do you think is going to happen if we add 4 lamps? If we add 4 lamps to the circuit, what's going to happen? The lamps will be more and more dimmer. So the lamps can hardly be seen. The light of the lamps can be hardly seen because the lamps become more dimmer, because the pushes started to be distributed on 4 lamps instead of 3 lamps only. What do you think it would happen to the circuit if we place 5 lamps, as shown in the picture? 5 lamps on this poor battery. What do you think? Of course, the lamps don't light. The lamps will not light because the pushes cannot be divided on 5 lamps. It will be so difficult. So the lamps start to be dimmer and dimmer and so on. They will not light. Okay, I hope that you understand. If you have any confusion, please, during the explanation, try to repeat the video as much as you can so you can understand easily. Page 64, modeling electricity. He told you that there is a group of learners modeled what happened in a circuit. Think about what is happening in the picture to help you to answer these questions. We have a boy here marked as a cell. He is the source of the electricity. And here is a boy labeled as lamp, which is going to change the electricity into light. And of course, those remaining children will be the wire, which is going to connect the lamp to the cell. So we have a complete circuit. Question 8. Why must the learners make sure they are all holding hands in the model circuit? If we consider that they are modeling an electric circuit, so they must hold their hands very well to not make a break. Otherwise, the electricity will not flow because one considered as a battery and the other as a lamp, and the remaining learners are considered as the wires. So they must hold their hands to keep the circuit complete. So the answer will be to make a complete circuit with no break. Otherwise, the electricity will not flow. This will not be a complete circuit and they will have a gap. Okay, question B. What happens to the flow of electricity when the learners don't hold hands and the model circuit is broken? If one of them left the hand of his friend, what's going to happen? Yes, there will be a break in the circuit. So the flow of the electricity will stop. Okay, question C. How could you model a switch in the circuit? Do you remember the switch? We said when the switch is on, it's closed and make a complete circuit. But if the switch is off, it's open and make a break in the circuit. So what they are going to do to make a switch in this model? Yes, they are going to drop their hands to break the circuit and then hold their hands again to connect the circuit. One of them should act like a switch, drop his hand and then hold his hand again so he can make a break and a complete circuit one more time. Okay, question 2, we give you some sentence and ask you to complete this sentence using these words. We have complete, negative, components, cell or battery, break, and switch. Question 8. For electricity to flow in a circuit, it always needs a power source or electric source, such as, yes, of course, it would be cell or battery, because as we said before, the source of electricity could be main electricity or cell or battery. And in this word bank, we only have cell and battery. Okay. Question B. The wires need to be connected to both the positive and what ends of the cell. Did you remember what we said about the cell? We said that the cell must have two ends, a positive end and, yes, a negative end. So the circuit would work. Okay. Question C. You can put electrical what in a circuit such as lamps, motors, and buzzer. Do you remember what are the lamps, motors, and buzzers known as? Yes, they are known as electrical components or circuit components. They are the components which make a circuit. We may place lamp or motor to spin something or buzzer to make a loud sound. So question C, the answer will be electrical components. Okay, question D. will only travel around a circuit that is, of course, complete circuit. Because if there is a break in the circuit, electricity will not flow and the lamp or other component will not work. So the electricity will only travel around the circuit that is complete circuit, and it will not flow if there is a break in the circuit. Last time we said that we make a break in a circuit for a purpose, such as to open or turn on or turn off our light, or turn on and turn off the electrical apparatus. Do you remember what the component which is responsible about the break in a circuit? Yes, it is the switch. Switch is a break in a circuit which we can use to turn a lamp on and off. Very well. I hope that all of you got the idea of this topic, and I hope that all of you enjoyed this session. Please recap your study notes as much as you can to be ready for your assessment. And next session, we will start our revision. We are going to start with skeleton and muscles. We are going to have a recorded video on Sunday to remember the difference between skeletal muscle and skeletal system and muscular system. I hope that you enjoy it. Thank you so much for your concentration, my beloved students. Goodbye.